Everyone, welcome back to the channel. In this video we will do thermodynamics. So basically therm means heat and dynamics means power. So to understand this, first of all we should know that what is work actually. So work is when we apply a force to an object and that causes an displacement of the object. Let's say an object is here and we are applying some force on it. So when we apply the force, this object will displace. So we will see that work is done. Now what is power? So power is rate of doing work. So work done per unit time. So it is known as power. Next is energy. So capacity to do work is energy. Next one is, now basically what is thermodynamics? So conversion of heat into power and power into heat is known as thermodynamics. So in the simple way we can say thermodynamics is the science of energy interaction and its effect on physical properties of matter. Now what are the physical properties of matter? Solid, liquid, gas, and these physical properties can be observed using human senses, right? Now in this topic we will study 3 E's, means energy, entropy and thermodynamics. So we have done energy, that it is the capacity to do work. Entropy means measure of randomness of any object. We will study it in the further topics. Next is thermodynamic equilibrium, right? Next one is application. So power generation is the application, refrigeration, relationship between properties of matter. Now next is thermodynamics can be studied using 2 approaches, microscopic and macroscopic approach. So micro, as the name suggests, it's a study of average behavior of the molecules that are consisting the matter. Yani, like we are studying the average behavior, like how the molecule at a molecular level. So it is also known as statistical thermodynamics. Next is macroscopic approach. So when a matter is studied at a large level rather than being studied on a molecular level, it is known as classical thermodynamics. Now if I talk about what is thermodynamic system, now we will see thermodynamic system is a quantity of matter or a region in space on which a study is focused, and we apply some thermodynamic laws. Let's say I have taken this region in space and I am observing that what is happening here. So it is my system only, right? Now again we have 2 approaches, control mass and control volume approach. In control mass we have finite quantity of matter and we are studying and observing that, right? In control volume approach we don't focus on quantity, rather than we focus on a particular region of, like in control mass we are focusing on this like particular 1 kg or something, 1 gram, right? So in control volume approach we are taking up a whole system, like region in space on which we are focusing. Now next one is, now thermodynamic system, right, can be divided into 3 further types. Now what is system? Now basically let's say it is a system. Now anything which is not outside the system we can say is known as surrounding, and the thing that is separating system and the surrounding is known as boundary. We will talk about it further. Now we have closed system. Now when we talk about closed system, so what we means, so it undergoes non-flow process and it follows control mass approach, means we are focusing on a particular quantity of matter. Now what happens in closed system? Here is system. So energy can enter and can leave or interact, we can see, but mass is fixed. So mass cannot interact or cross the system boundary. Only energy is able to cross the system boundary and can interact, like we can understand from this picture or diagram. So here we have something like piston cylinder which is having no valve. So now here energy can enter and exit, but mass is constant and it remains constant till the end of process. So we have some examples: ice cream freezer, refrigerator, pressure cooker. Now when we talk about open system, it's a flow process. Like in such a system, we can say energy and mass both can interact and cross the system boundary. There is no restriction. Now here we can represent like energy is coming and energy is going out. The similar way mass is coming and going out. For example, steam generators, boilers, motor car engine, turbines, IC engine, pump, human, and everything in the open system follows a control volume approach, like we are taking a particular region in space and we are focusing on that actually. Next is isolated system. As the name suggests, isolated. Neither energy nor you can say mass can interact or cross the system boundary. So, for example, perfectly insulated thermos. Like when we talk about thermos, some of the thermoses are like they can be isolated, but they are not actually, right? And universe is also an example of it. As I told you earlier, anything which is external to a system is surrounding, and it is a system boundary, and system has finite mass or volume. System boundary can be real or imaginary, fixed or moving, right? Mathematically, boundary has no, if I talk about boundary, it has no thickness, so the volume of boundary is itself zero. Now what is control surface? Like boundary of the system, like the system that is made up of which surface, like these walls are the control surface, can be real or imaginary. So that's all for this video. Thanks so much for watching. Till then, keep learning and keep studying and whatever you can, and do not forget to tell me down in the comments if you have any query till now. I will definitely try to solve it. Thank you so much.